Today, like we said, we're going to talk about elm, beech, and tulip trees. In the past, I had trees grouped together based off of similar habitat or similar leaf shape. These ones are kind of not really grouped together based off of how they look, but more so how dominant they are at wood end. These three trees are our most dominant trees at wood end. So if you go to wood end, you're looking at the trees, it's likely one of these three that you're looking at: American elm, American beech, and tulip tree. Now, similar to last time, we have new people and returning people for today's tree ID course. So I'm going to have every single slide from the first two courses, as well as some additional slides on new topics. I will highlight terms and characteristics that are pertinent to the trees that we're talking about today on slides that are repeats. I will not go too much into depth on things that were discussed in the last two, but again, the presentation will be shared with everyone through a PDF as well as a recording of this, so you'll have plenty of time to go back through the information and learn all you can about trees. So our new topics today, we're going to talk a little bit about plant reproduction and threats to trees. So when I say threats to trees, I mean more so canopy trees, because next talk we're actually going to be focusing more on understory trees and even talking some about shrubs, which are still obviously woody. But with that, I'm going to go ahead and get started here. Again, like Diane said, if you have a question, the chats are a great place to put those questions, and Christian will be reading those to me. I will have structured breakpoints after I complete subtopics throughout the presentation, as well as plenty of time at the end. Because I have added a decent amount of new information, I will be a little bit speedy through the repeat information. So again, don't feel free to ask any questions, or if you want me to repeat something, I definitely do not mind. Our key at the end, which we usually do, we go through a sample of a twig through a key. This key is a little bit longer, so we'll have to leave time for that. So like I said, our trees, American beech, which is in the family Fagaceae. The last time I started talking a little bit about plant taxonomy. The Fagaceae is the family that includes oaks as well. So you'll notice a similarity between oaks and beeches, especially in the winter when they seem to hang on to their dried leaves, despite them being nice and not green anymore. They still like to hang on to them throughout winter. Tulip tree, which is also commonly referred to as tulip poplar. It's actually not a poplar. It's in the family Magnoliaceae, so magnolias. You'll notice that the flower of the tulip tree looks strikingly like our native magnolias, more so like our southern magnolia than anything. It has very different reproductive features than a poplars, like our eastern cottonwood, which is a true poplar. And then elm, so we have our American elm in the Ulmaceae. So that includes all of our elms, which is a very distributed family throughout the world. Lots of European and American species, as well as a really popularly planted Japanese tree, Japanese Alcova. It is a very disease-resistant and urban tolerant tree that is planted popularly in urban areas. So we'll talk about how our American elm compares to the elms and Zelkova listed here. So we'll get to that at the end. So first, obviously, how do we identify trees? Well, today, again, like I mentioned, we are using our Muncher's Keys to Woody Plants. It's a very expanded guide, so it doesn't just include native species to North America. It also includes a lot of our cultivated landscape species and invasive species, non-native invasive species. Its key is a little bit different because there's actually two keys within this key. You have to first go through one key that will decide what genus of tree you're looking through. So for our elm, Ulmus americana, Ulmus would be the genus, and Americana is our species. So first you have to decide what genus, and then you go to another key, which is the Ulmus key, and then you use that to identify which species. And again, we'll see what this looks like once we get to it at the end. So this is an example of a dichotomous key. And remember, there are some apps that will help you identify trees as well. Similar to our tree finder, which we used in the first class, the Muncher's Keys to Woody Plants does not have species descriptions or illustrations. I mean, there's not one picture in that book. So it is always good to have other field guides that will provide those species descriptions, as well as some really nice imagery and illustrations for you to better understand the tree that you are looking at. As well, today we're actually going to be using a hand lens. I have a picture of a hand lens being used to a key. It was necessary in identifying our sample, so it's always good to remember to have a hand lens or something that can look at small features on you while identifying plants. So I sent out again our link to a list of terms. In here I've bolded terms that are pertinent to our trees today. So pinnate, which refers to the venation of our plants, are pinnate, resembling a feather, just one main stem with branches off of that stem, just like a feather looks. So again, I'll explain this when we get to the venation part of our class. A fascicle is a type bundle or cluster. This is very apparent in pine trees. Pine needles are always grouped together in clusters, and that cluster is called a fascicle. So scabrous, rough to the touch, very apparent when we talk about our elms, when we are discussing how the leaf feels. Denticulate, which it refers to dentate with very small teeth. So again, a reminder, dentate is just sawtooth margins along a leaf. And then we also have doubly tooth or doubly serrate. Remember, serrate is a little bit different from dentate because a serrate leaf will have the teeth pointing forward towards the apex of the leaf, which instead dentate just points straight out. And doubly tooth means that the serrate teeth of the leaf are also serrate, so they're doubly serrate. Another term commonly used for this is biserrate, and we'll see an example of this when we get to our American elm. That's just a reminder of all the terms that can be used when identifying plants, and there are many, many, many more. Now again, alternate versus opposite is always the first thing that you should look for when identifying a plant. Even in our key today, you can't even start going through the genus key before deciding if it's alternate or opposite. To make the key a little bit easier to go through, it groups its genuses or genera based off of whether there are plants with alternate leaves, plants with opposite leaves, or opposite or world leaves. It groups the genera based on that before you can even start the key. So it's always important to use this characteristic as your first feature that you look for. Now again, if you have oppositely arranged trees or woody plants, your likelihood of identifying it is a lot easier just because of the fewer species that are oppositely arranged. I just want to remind everyone of the little saying, Mad Vibes Lonnie, that encompasses 5 groups of plants that are oppositely arranged: are maples, ashes, and dogwood, so mad, our viburnums, and our linicera, or honeysuckle. So those are some of the oppositely arranged trees, and I couldn't even begin to list the alternately arranged. It's basically everything else. So again, with our twig anatomy, I just want to remind everyone what we pay attention to the most, and that is our leaf scars, the point at which the leaf was attached to the stem, our axillary and terminal buds, mainly referring to the position on the stem of those buds, and the features of those buds are usually important in identifying. So those are the 3 main parts of the twig that we look at. So I did mention terminal versus axillary, just another reminder. Terminal or apical refers to the end of the stem. So it is the bud at the end of the stem, the terminal bud. And the axillary refers to a bud present in the axil of a leaf. So remember that an axil is just an angle between 2 features. An axil can exist between primary and secondary vein. So again, the primary vein and the secondary vein, there's an axil there. There's an axil here between the leaf and the stem. Just any place where there's an angle between two features. And so that bud, because it's in the axil, is an axillary bud. Last class, I did have a question about flower buds and leaf buds, so I wanted to make a slide just talking about that. Flower buds are identifiable because they are usually more distinct. They're larger, rounder, and fatter than the leaf buds, the other buds that are present along the stem. On some species, like our red bud, the flower buds open before the leaf buds, so that's another way to tell which bud you might be looking at when the time of it opening. A leaf bud is usually pointed and less significant, so in the sample in our picture, you can tell the difference between the flower and leaf bud. They're distinctly different sizes. But they can get confusing sometimes because some buds have both. We'll actually see an example of that when we get to our American beech. But a really classic example is when horse chestnuts, the terminal bud, unveils the really big compound leaves with these amazing flowers. It all comes out of just one bud. So sometimes there isn't a difference and it's just the same bud. But I just wanted to talk about that for a second because of the question from last class. So I'm just going to go straight into talking about twig and bud features for our three species. And at the end of these three slides, I will pause for questions. For our American elm twigs and buds, our leaf scars are arranged alternately. So our buds and leaf scars are alternate on the stem, never opposite from each other. Buds are enclosed in two or more scales. You can kind of make out the scales here, the little lines that you see here. So scale are adapted leaf features that protect the bud. They are brown, equal-sized. They're two ranked, which means that the buds are 180 degrees from each other along the stem. And you'll notice that as you look at our twig here, that it creates this zigzag pattern because of this feature, that the buds are always 180 degrees from the other bud. And they're usually not centered over the leaf scar. You can see that the tip of this bud is not centered over the leaf scar. They're a little bit askew. This is another very characteristic feature of elms. And the twigs have little to no hairs on them. So they're very smooth, or in a botanical terminology, glabrous. Our American beech twigs and buds are very identifiable. Sometimes you might run into them by accident while walking in the winter, and you'll feel a very pointed feature, and that's the bud. They are very long and conspicuously pointed, and I often run into them by accident when I'm walking through the forest. And then you'll notice the dried leaves that persist throughout the winter. So very identifiable in the winter. And like our elm, our leaf scars and buds are arranged alternately along the stem. For our tulip tree, I think the color of our tulip tree buds and twigs are what make it so identifiable. It's a very purplish to reddish. You'll notice on the rightmost picture, our purple, very purple long bud, which is much larger. Our terminal bud is much longer and conspicuous than our axillary buds. So our terminal buds do have flowers in them. And you'll notice that because of how tulip trees spread, their twigs kind of curve upwards towards the sky. And that is so that when it flowers and fruits, the fruits are wind dispersed, so they'll have more of a kickstart in falling since they're from a higher and more upright angle. And like our other two species, our leaf scars are arranged alternately, and you'll notice our little white dots or lenticels along the stem. And remember, those are gas exchange pores for our trees. So for bark types, we're going to really be focusing on our smooth, unbroken bark when we talk about our American beech. We will talk about scaled bark, and so I'll touch on vertical strip too with our American elm. it is a feature of its younger bark, which is much more different from its mature bark, which is shows intersecting ridges and furrows. So both our tulip tree and our mature American elm is similar to our white ash with its intersecting ridges of bark. But again, like I said, the American elm bark goes through a series of stages as it matures, looking different each time between very young, somewhat young, and mature. And we'll see that in a second. Right here, an American elm. So you'll notice it's very vertical stripped or scaly when young, and it's actually even squishy, especially when it's really high in humidity outside. So right now, our American elms would probably be extra squishy. So most bark you come across is pretty tough. This one, you can actually put your thumb up against it and push into the tree and squeeze it, and you can actually tell that it is a squishy bark. So that is a very characteristic feature of elms. As it matures, the vertical strips become more apparent, and those strips later become the tough ridges that are no longer squishy and are the exact opposite. Very, very tough. Another characteristic feature of this tree is our inner bark, our alternating red and white inner bark that you can see here. Has a little bit of red and a little bit of white. This feature will become important when we discuss how you differentiate two really closely related elms in North America, the slippery elm and the American elm. For American beech, I sometimes call this graffiti tree. The tree with this very, very smooth bark often invites people to carve things into it. It is a nice canvas. Now this obviously is not good for the tree, opens us up for disease and insect damage. These markings will also expand in size as the tree grows. And if you were to complete just one single line of carving around the tree, you would cut off all of its basically the veins and arteries of the tree, its circulatory system that takes the nutrients and water from the roots up to the top of the tree. When it matures, it stays smooth and unbroken, but it can become mottled different colors throughout an age, kind of having like green splotches on them. Our tulip tree also goes through some stages of maturity with the bark looking different. It's a very straight trunk tree, so it just goes straight up without even curving or bending at all. It's just a very straight trunk, which is why it was a very popular tree for dugout canoes. Its young bark is kind of a grayish to even somewhat purple with these white lines. These white lines will become these cracks. They develop into cracks and then later into these ridges and furrows that go straight up all the way to the top of the tree. And they kind of goes from a whitish purplish to a really darker gray to brown. I will take this time real quick to just pause for questions before getting into our more spring and summer characteristics with leaves, flowers, and fruits.
We have a question from the chat. And so someone was wondering if you could give an idea of roughly the ages in the tulip tree that these changes occur in.
So I would say that this right here in the middle, so this would be up until we get to here, which would probably be about, I'd say 30 to 40 years. And then here there's not much difference between the ages of these two trees, probably only like 10 years, whereas there's a lot more difference between the really young and the somewhat young. But again, this all depends on how fast the tree is able to grow in its conditions. If it has all the light it needs and really good water, it can mature to this pretty quickly. Sometimes it can be stunted under like partial shade and grow slower. But I would say generally it would take about 50 to 60 years to reach this full bark maturity, and this would be about around 25 to 30 years.
Great. I don't see any other questions in the chat for right now.
All right, great. We shall continue on. So a reminder of simple versus compound. Once you do decide that you have an alternate or opposite tree and you do have leaves, the next feature that you want to look at is whether your leaf is simple or compound. And remember, this really depends on the location of the bud in comparison to the leaf that you're looking at. The bud will always be at the bottom of the leaf where the petiole, the leaf stem, attaches to the woody stem in which it's growing on. So our bud and stem will be right here on a simple leaf, whereas in our compound leaf, it's still right at the stem, and there are no buds between the leaf stem and the leaflets. So you follow all the way down until you find your bud, and that's how you determine how big your leaf actually is. And then you can count your leaflets from there. None of our species today have compound leaves. We are going to be dealing only with simple leaves today. For our shape and arrangement, I want to highlight our ovate and obovate. So ovate just refers to egg-shaped, looks very much like an egg there, and obovate just means the opposite of ovate. So it means that it's like an opposite egg shape. So the fatter part of the egg is at the tip of the leaf instead of at the base, and elliptic, which is just very oval shape, being widest in the middle. For our leaf bases, we actually have a lot of different types of leaf bases for today. We have our elms, which are very much oblique. We'll see that when we get to our elm leaf. Our tulip tree can be truncate or cordate, so it cut off or heart-shaped. And our beeches are cuneate, which just means narrowly triangular with an acute angle, so less than 90 degrees down there. At our apex, so the truncate for the base refer to the tulip tree, and it also has a truncate apex, so it's just like both the tip and the base of the leaf had just been chopped off. For our beech and elm, the tips of the leaves are either acute, coming to a triangular tip, just similar to a cuneate, but on the leaf apex, and then acuminate, which means it's pinched to a tip. So our leaf anatomy, remember when I mentioned pinnate at the beginning, it refers to resembling that of a feather. So we have pinnate down here, we have our primary vein, and our secondary veins being branched off. When we discussed our trees last time, all of our trees were lobed, similar to that of a maple, as well as multiple veins. So they had many primary veins from the, so they're palmately veined, several primary veins diverging from the point where the leaf stem, the petiole, becomes the vein. Despite our tulip tree being a lobed leaf, all of our trees and leaves are pinnately veined today. For our margins, we have our tulip tree, like I said, is lobed, but within those lobes, they are entire. So the lobes of the leaf are very smooth, not showing any teeth. Our elm is doubly serrate or biserrate, with remember the teeth pointing up towards the tip of the leaf, and then dentate for our beech. So remember with symmetrical teeth that point straight out from the origin of those teeth, and more so related to our beech, our teeth are a little bit smaller, so we call it denticulate with fine dentate teeth, really tiny ones. So I've mentioned sun versus shade leaves in the past two. Like I said, I want to have all the information from the previous two classes in this presentation, although this feature does not really apply to the species that we're talking about. But in general, our sun leaves at the top canopy are smaller and more lobed than our shade canopy, our shade leaf, which are in the bottom canopy, which are larger and less lobed. Our lobes are a lot more distinct here in our sun leaves. So our American elm. So you can see this very strongly oblique base. American elm is a very good example of what an oblique base looks like. The leaves are alternate and simple. They're pretty long, 10 to 15 centimeters long. They're ovate or obovate or oval, so the part in which the leaf is widest changes. Sometimes it's either at the base, in the middle, or at the tip of the leaf. The apex is acuminate or abruptly pointed, so you can see that really pinched tip of the leaf. It can be smooth to scabrous, so rough to the touch above, but is usually smooth beneath. Our leaf margin is biserrate, so you can see this tooth has another little tooth, so it's doubly serrate or biserrate. And the leaf veins extend to the margin without branching. Sometimes one or two of the veins will branch, and we'll see that when we compare it with our slippery elm, but for the most part, most our secondary veins go straight up to the teeth without even branching into another vein. The American beech, again, alternate and simple. They're cuneate at the base, acute to acuminate, and the marges you can see are very small teeth, so they're denticulate, but sometimes they can also be sharply serrate. So denticulate means small dentate teeth. If you want to use the same term for serrate, you would use the word serrulate. And then the leaf surfaces are very smooth above and below, much not like our American elm. It's very, very smooth. You don't even feel any hairs or roughness to the touch. Our tulip tree, I think, is interestingly shaped. I like to imagine it is shaped like a cat's face. You'll see my little illustration down here on the right. So I call it like the cat-faced tree a lot. It is, you can kind of imagine the parts of it, the ears, and you kind of draw in the eyes, but it's a little bit cat-shaped. They're alternate and simple as well. They can be cordate, so sometimes there's this fourth lobe down here at the bottom. So when the leaves refer to the 2 apical lobes and the 2 to 4 basal lobes, the apical lobes are up here, and our basal lobes at the bottom half of the leaf are referred to here. So 1 and 2, 3, 4. This one can be larger in some leaves and extending downwards, making the leaf base cordate. But it does look like our apex and bases are cut off, and sometimes you can even have a little notch here at the tip of the leaf. And this leaf is also very smooth, similar to our beech. So again, I'll pause real quick for questions before I go straight into flowers. All right. Well, with that, I will continue. So we talked about inflorescences. Today we're really going to be talking about a raceme. So raceme just means a single stem that the flowers are born on, and each flower born off of that stem has its own stem or pedicel. So a raceme will refer to the arrangement of the flowers for our elm. And for our tulip tree, we have 5 meris and 4 meris flowers here. Our tulip tree is 6 meris, so having 6 flower petals. So that is just a reminder of our flowers. And we had gotten into some discussion about plant sexuality, so monoecious versus dioecious, which is the next slide. But first, I wanted to talk about perfect flowers, so flowers that are both male and female. This is apparent for our tulip tree. They have both the male stamens, which have the pollen, and the pistil, which includes the ovary and ovules. So the ovules in a flower will become the seed, and the ovary will become the fruit. So sometimes these flowers can pollinate themselves. That refers to self-pollination. But most of the time, flowers need pollen from different individuals, or they will not be able to pollinate. I will discuss that more when we get into monoecious versus dioecious. We'll get into that. So monoecious means a single house. It means that the male and female reproductive structures are one single individual. Sometimes it can be the same exact flower, like we said, are perfect flowers. But in the case of our American beech, it is a monoecious plant, but there are separate male and female flowers. There's also dioecious, which refers to double house, which means that the male and female flowers are on separate individuals. And the best example of this is our hollies. So if you wanted to have a holly tree that had berries on it, you have to make sure that, one, you are planting a female. Our female hollies are the only ones that are going to be able to fruit. And then you'll have to make sure that there's at least a male holly nearby to assist in pollination. There are some trees that self-pollinate, referring to some of our fruit trees. So apricots, nectarines, and peaches are able to self-pollinate, which means you don't need to plant any other individuals, just one, and you'll be able to have fruit. But like our species today, you would actually need at least two individuals to be able to form fruit. For the example of our American elm and American beech, they can self-pollinate to a degree, but it was found that for an American elm, only 1.5% of self-pollinated flowers were able to actually produce viable seed. And this is a defense for the plant, actually, to increase genetic variability within the population, and that will lead into more long-term health for the tree as a whole. So our American elm flowers are either born in fascicles, so in a cluster, or in a drooping or pendulous raceme. So remember that stem that then has stems branching off of it, and those branch stems are the ones with the flowers. They appear along twigs and clusters of 3 to 5, and they are apparent before the leaves. American beech flowers, they're very inconspicuous, and you can see here that they come out of the same bud as our leaves, so they emerge at the same time. So our female flower is up here, and our male flowers are down here, a little bit larger, so you can see the distinction here. So these are all the stamens and anthers with the pollen, and then this will form, the female flower will form the fruit. Our tulip tree is solitary at the end of branches, so that terminal bud that I mentioned, which was a lot larger than our axillary buds, it has that flower, and it is very tulip shaped. Tulip trees are interesting because they're only receptive to pollen for 12 to 24 hours, so they produce a boatload of nectar for pollinating insects to really attract them, to get them into the flower within that time frame. So insects like flies, beetles, honeybees, and bumblebees will pollinate tulip tree, whereas the American elm and beech are more so pollinated by wind. So before I get into fruits, I'm just gonna quickly pause again for questions. If there are not any, I'll go straight into fruits. Our fruits today, we mentioned a lot about samaras in our last time, especially in reference to our maples. Remember, those are little helicopters we used to play with. So we have samaras today, tulip and elm. Both have samaras, which is, as a reminder, is an achene. It's an achene, a dry indehiscent fruit, and a samara refers to a winged achene. An American beech is actually a nut, which again shows its relationship to oaks, which obviously the acorns are a nut as well, and they are all in the same family. So a reminder of all the other types of fruits you can have on a tree. So like I said, our American elm is a samara, but look a lot different than our helicopters that we're used to on maples. The wing is actually flat, and the seed is right there almost in the middle of it. Very differently shaped samara. Our American beech fruits are have a prickly husk with a nut inside, usually in 2s or 3s. along its stem. Tulip tree has a cone of many, many, many samaras grouped together. So it has the flower becomes this at the end of branches, with each of these being a separate fruit. Our samara, and this one behaves more like our helicopter that we see in maples. They're one-winged, and it's said that they resemble the front keel of a boat, just the curved edge. The American beech nuts they're usually produced in great abundance, and lots of small mammals feed on them, as well as cedar waxwings and other birds. Tulip and elm, which are wind dispersed mostly, are eaten by many birds and mammals as well. And the tulip tree seeds usually persist throughout the winter. So I'll take any questions on fruits, and we're going to get into a comparison with other elms and our Japanese Elcova, and we're going to stay on the American elm, slippery elm, for a little bit.
Okay, we have a question. Which one is more common for eastern trees, monoecious or dioecious?
So monoecious is more common, definitely. There are less trees that are dioecious. If you think about a monoecious, it's a lot easier for reproduction on a tree because if you need to, self-pollination can occur. Whereas in a dioecious, you can't do it without another tree. And usually dioecious trees require a pollinator and are seldom wind pollinated. So our monoecious trees more commonly are wind pollinated, which increases the ease for pollination.
Great. We have a question. Can one samara from a tulip tree form another tree?
Yeah. It's got the seed in there. So as long as it falls in a viable location and germinates, it can become a tulip tree. Usually trees that produce lots of fruits like tulip tree, it's expected that only a small percentage of the seeds are going to be able to become trees, but the others will become food for wildlife.
Great. That's all we have in the chat for right now.
All right. Well, so we're going to get into comparisons, and we're going to start with the hardest one, American elm versus slippery elm. Now, when I look at these pictures, I don't really see a lot of difference, and that's the agreement a lot of keys. A lot of keys refer to different features when trying to differentiate American elm and slippery elm. Some keys disagree with other keys, and it's just always difficult to separate these two species in the field. I just want to quickly mention just this feature right here. I refer to this alternating white and red inner bark of our American elms. This is not an apparent feature in slippery elm. So if you were to shave off the bark and look at the inner bark in American elm, you would just see red. You would not see any alternating colors. But I do want to read some of what the key of Flora Virginia says, and you'll kind of understand that there is not a huge difference. So Flora Virginia describes an American elm as leaf upper surface glabrous or moderately scabrous. Slippery elm described as leaf surface slightly to very strongly scabrous. Not much difference there. For American elm, leaf underside glabrous to tomentose. So it's either not hairy or very hairy. So that's helpful. And as slippery elm, it says the leaf underside is tomentose. So you would only find hairy undersides of leaves on a slippery elm. It does not say that slippery elms have smooth undersides of leaves ever. And it says American elm is with or without tufts of hairs in the vein axil, so between the primary and secondary vein. But they say in slippery elm that they do have them. Lots of confusion, but the main feature that it does refer to is the bark. So it says that American elm has this alternating layers, whereas slippery elm does not. So when you really want to be able to just separate these two species based on leaves, and the Flora Virginia, which is a very, very good key, doesn't even use leaves mostly to separate, and it comes down to that inner bark feature. So you really have to know what you're looking for sometimes. With our other elms, it gets a little bit easier. Our rock elm has these corky wings. on them. Now, sometimes in slippery elm, the leaves can be toothed or three-lobed at the apex, having a lobe here and a lobe here. For the life of me, I was not able to find a picture of it, and nor did I know of a slippery elm I could find with that feature. So I'm not able to show what it looks like, but just imagine this tip right here, there being three of them on the leaf. So three-lobed, and sometimes described as having much larger teeth than our American elm. But for a rock elm, if you see some quirky wings on it, it's definitely not an American elm. It's probably a rock elm. But then you can also have a winged elm, but those wings are much, much larger and more apparent than our rock elm, with our leaves being a little smaller and a lot narrower in our winged elm. In our Japanese Elcova, I think the biggest difference here is its bark. It becomes, it exfoliates with age, unveiling a reddish inner bark, and it has these vertical lenticels along it too. The leaves are very small, very narrow, and more triangular in shape, and is very smooth as well. So not scabrous or rough to the touch or really hairy at all. And then one more comparison that I was asked to make was just all these leaves look similar. So just how do we differentiate chestnut oak, American chestnut, beech, and elm? There was a Maryland Native Plant Society discussion on Facebook recently about it. Someone found American chestnut, and it's a good just reminder to show that there's a lot of things that can look similar, and this will kind of lead into our next slide, which talks about the threats to trees, which of course the American chestnut is going to be highlighted in that. So our chestnut oak has rounded lobes, so the teeth are not sharp, they're very rounded. The bark is very blocky, so you'll get these very large plates with these almost vertical lines going through it at points. American chestnut has very, very large leaves with very long teeth, and the bark has these uninterrupted ridges that go almost straight up the trunk, similar to what our red oak bark looks like. Our American beech, with our very small teeth, is also smooth, similar to our American chestnut, but of course the striking feature is that smooth and the broken bark. And our American elm, or elms in general, have a more rougher leaf, forward pointing teeth, that oblique base, which is not as apparent on this leaf, but is still there, and our squishy scaly bark or our intersecting ridges on mature bark. So that is it for the comparisons. I'm going to talk about threats to trees before I pause for questions, and then we'll go straight into identifying our tree sample. So the first one, obviously related to one of our main trees today, our American elm, is the Dutch elm disease. So it's not actually Dutch, it's just named so because of the Dutch scientists that worked very hard to figure out and learn about this disease back in the 1920s. So it was called Dutch elm disease after them. It's a fungus that infests the xylem of individuals. So the xylem is one of the types of veins and arteries of a tree. It brings water and nutrients from the roots up to the leaves. American elm trees are highly susceptible. The ones in urban areas were mostly killed. Hundreds of thousands of them were killed since the 1930s when it was introduced. The ones in the forest, luckily, were more able to survive because this disease spreads by beetle. In an urban area where streets were just planted with elm, it was easy for a beetle just to keep hopping to the next one. But in a forest where elms are kind of shielded by other trees, it was more difficult for the beetles to get to those elms. So the ones in our forest, like we have a very mature American elm in the forest of Woodend, and since it was not influenced, we now have a lot of its offspring throughout the forest as well. So chestnut blight obviously refers to our American chestnut. It is also a fungus. It's a canker fungus, a canker disease that appeared in the early 1900s as a result of the importation of Asiatic chestnuts, which are very resistant to the disease since they evolved with it. I will mention that the Dutch elm disease is also of Asiatic origin, and so is our emerald ash borer. You'll notice a trend. A lot of our non-native species that do really well here are of Asiatic origin, and that is just because of these similar climate conditions in Eastern Asia as well as here. It is a nice temperate climate, so very similar ecology. So when those species come here and when our species go there, they do very well without their usual predators. But since the chestnut blight was in the United States and did not have any natural predators, or did our trees have any resistance to it, within 50 years, 99.9% of our American chestnuts were reduced to stumps. It is a very unfortunate disease. You can come and actually see examples of it at Woodend. We have 24 American chestnuts planted. This is actually one of them right here. About half of them have already been purposefully infected with the chestnut blight in order to test their survival. So this is a product of a long-term traditional breeding program that bred American chestnuts with some Chinese chestnut, and they back-crossed to produce a American chestnut that is 94% American, about 6% Chinese chestnut. So we have those planted, and we're hoping that 6% Chinese chestnut will allow for some resistance to the fungus. A more recent one, or emerald ash borer, has come in since 2002, and it is an insect that just reproduces extremely well, and then once they all get into one tree, they can decimate it within a year. Even mature trees, if there are enough borers, it can die within one growing season. So since its introduction in 2002, tens of millions of ash trees have been killed, and this is still happening at Woodend, as we still need to lop off the dead parts of our ash trees in the forest, especially ones that are negatively influencing trails and fens if they were to fall. So I'll pause here because we're going to go straight into our identification of a sample.
We have a question about rock elm, and this person was wondering how common they were in Maryland.
I personally have not seen a rock elm, so I would say not very common. You would more likely run across an American elm or a slippery elm. I think same goes for winged elm. They're here, they'll probably be in more larger natural areas, and you would really have to look for them. But personally, I have not seen a rock elm or winged elm in my explorations of our natural areas.
Okay. And is the winged elm native?
Yes.
Okay. And then the last question I see in the chat is if it was true that white ash is the most common tree in the DMV.
I do not know that. That would be really cool to know, and also kind of sad because it probably won't be the most common tree in the near future, but I actually do not know what the most common tree in the DMV is, but ashes are very, very, very widespread. Okay. Yeah, I have a little thing here that says ash trees are one of the most valuable and abundant North American woodland trees. Estimates in the United States between 7 and 9 billion in the entire country. So yes, they are quite common. Any other questions real quick?
This person was just saying maybe the tulip tree would be the most common or maybe the second most common.
It's definitely very common. It is the most common at Woodend. More so common in younger, more disturbed forests since they are that stage that comes in not too long after clearing, since they are a sun-loving species, but they do not grow in well-shaded forests.
Great. That's it for the chat questions.
All right. So we're going to use our Muncher's keys to woody plants to identify a sample here, an American elm sample. So remember, when we start, we have to do a key to genera. So you see here, this says Serona up here. Sometimes Latin pronunciation is really dependent on how you like to say it, or but that is a genus. So if we were to say that leaves are greater than 70 centimeters wide, we would go to the key for that genus, which is separate from the key that we are about to use. And before I was even able to start at this number 1, I had to already go to the group that is plants with alternate leaves. So that is really the first decision you're making. And then within that group, we start our genus key. So our leaf is definitely not 70 centimeters wide. We're only about 7.5 centimeters wide. So we go to number 2, where it talks about whether they're crowded and overlapping at the base. So basically these leaves would just be on top of each other along the stem, and being very, very, very narrow. So linear lanceolate. So it's very narrow, or at least 10 times longer than wide. We definitely do not have that. It's not a woody grass either. So our leaves are not crowded and overlapping, are less than 10 times longer than wide. So we go to number 6, since if we were to choose that first 2, options 3, 4, and 5 underneath that first 2, but since we chose the second one, we go straight to 6. We're asked if our leaves are lobed, or if they're entire or toothed but not lobed, so our leaf is not lobed. And then we skip all the way to 43, where it asks if it is entire or toothed. Our leaf is definitely toothed. So we go right below to 142. So it asks if leaves are toothed only at the rounded apex, so really only at the top here, or if it's toothed at least halfway toward the base, so at least halfway to here. We have teeth all along the edge of our leaf, so we're definitely going to choose the second 142, 142B. And go to 145. If leaves have really hard, sharp spines, ones that would definitely cut you if you were to come across it, or if leaves were toothed but lacking these sharp spines. So we don't have a holly or a yucca. Our teeth are not sharp spines. So we'll go on to 145B, where it asks if our stems have thorns. Our stems do not have thorns. They lack spines or thorns. So we'll choose 147B here. And we'll go to 157. I just want to mention, like, this is how many trees there are. Each, like 162, even though there's 2, it has 2 genera in it, and each genera has its own species. So this key encompasses many, many, many species. For a small book, it's a very useful key. So 157 is asked if our plant is a climbing vine or if it's a shrub or tree. So that, again, this key is not just trees, it's really anything woody. Our plant is obviously a tree as it's standing tall here, so we're going to choose 157B. And ask how tall our tree is, or tree or shrub. If it's low or greater than 20 centimeters, our trunk is definitely greater than 20 centimeters tall, so we'll choose our second option here. And it asks about how many main veins we have, or primary veins. We only have one main vein that extends from this leaf stem or petiole, so we'll choose 165B. We'll go to 175, where it asks about stalked buds. So it just means the bud isn't attached directly to the leaf stem, it's on this stalk. So I just showed a reference here. Our leaf buds are not as such, they're attached directly to the stem and are not stalked. So we choose 175B. And we go into, what does our leaf base look like? If it's oblique or symmetrical or slightly oblique. It is oblique. Most of our leaves are oblique, so we'll choose that first. 181. So you'll see that we're getting pretty close. It's right there. That'll be in our next couplet. And 182, where it asks if we have doubly toothed leaves or singly toothed. You'll see I pointed out to some apparent doubly toothed features here. And because of that, we now know our tree is in the genus Ulmus right here. So now that we know it's in that genus, we can go to the Ulmus section of our key. And since we have leaves, we're going to use the summer key. There is also a winter key within these. So this book is also useful for identifying trees either in the spring or the winter, because it doesn't have it for all genera, a winter key, but for a good amount of them, they do. So in this one, it asks for if the leaves are very scabrous on the upper surface, sometimes 3-lobed at the apex, or if our leaves are smooth or nearly so on the upper surface, sometimes somewhat scabrous. So I showed a picture of what the tree finder said, because I actually do not like this difference, because differentiating very scabrous versus nearly smooth is very difficult. And unless you know what very scabrous feels like, this is not helpful. So I wanted to show what the tree finder says about differentiating slippery elm and American elm. And it actually refers to the bottom of the underside of the leaf, where the slippery elm would be rough beneath as well as on top of the leaf. And our American and cork elm would not be rough beneath and smooth. So I just showed a picture of the bottom here. It isn't really hairy. It's not rough. So because it's not rough, we will go the route of saying it is not in the. We're going to go the 2B route because slippery elm is almost rubra right here. So we want to go away from that species. We're going to choose 1B. But remember that there's also the alternating bark feature, but neither of these keys actually refer to it at this moment. So if we chose 1B, we would get to our couplets number 4, where it asks if our twigs and branchlets are mostly with corky wing-like ridges. Ours are smooth, so we'll choose the 4B. And then it asks about the length of our leaves, if they're 10 to 15 centimeters or 2 to 6 centimeters. Our leaves are 10 to 15 centimeters long. You see this one is about 11 and a half. And then we go to 9, our last couplet, and it asks if the leaves are hairy at the margins or glabrous. So in the case of my very tiny hand lens, that you can see these tiny little white hairs that extend off of the leaf. This is also referred to as cilia, just leaves at the margin of a leaf, or hairs at the margin of a leaf. And since they are apparent, we know that this is Ulmus americana, or an American elm. So always important to have a hand lens. It took me many tries to get this picture, and it turned out really good. So you can see these hairs. So with that, there's our resources. Again, these will be shared, so you can click these links. And thank you for joining today. I hope it was helpful, and I'll take some last questions real quick.
Someone was wondering if you found the tree finder dichotomous key to be more user-friendly than other ones, and they were wondering who the author was. I believe it's May Watts.
I could go get it real quick. I don't have it in front of me at the moment. It's easy to look up if you just look up tree finder.
They were wondering about the more detailed one.
Who's it by? So it's originally by Edward A. Cope, but then it was originally by this guy named Muncher. I don't really know his first name, but then it was updated by Edward A. Cope he made an expanded guide of the original keys to woody plants that included cultivated species. So there's kind of 2 authors. And the tree finder is most definitely more user-friendly. If you're getting a first one, it's $6. It's available at the ANA shop. It's very useful. It has a lot of the native trees. But if you want to start identifying landscape trees in people's yards, or trees in cities, or even non-native invasive species, you're going to have more luck with some more advanced keys like the Muncher's one that we used today.
Thank you so much, Bradley, and thanks everyone for joining us. Have a wonderful evening.
Hope to see you all next time.